the IoT Connected Air Quality Monitor to detect and measure particulate matter concentrations conducted. So what is particulate matter? They're essentially liquid particles suspended in the air, and they can range in size between 2.5 and 10 micrometers, and anything less than 2.5 are considered air pollutants. Air pollutants are a huge issue, as we all know, and the World Health Organization states that 7 million deaths have occurred because of air pollution, and the proposed solution is to have an affordable personal air quality monitoring device that has immediate alerts and lets other people know about them. And so I conducted background research investigating dust sensors and particulate matter, as well as particle pollution itself. And so I had to create an engineering goal, and so I created a device called Pika Particulate Matter Internet Enabled Quality of Air Sensor. And this device is targeted to be low cost, small size, portable, and connect to the IoT server. And so for my design requirements, I have particle sensitivity, so it should be able to pick up anything less than 2.5 microns. It should connect to IoT servers, run on 9-volt battery, be compact, and all the circuit boards should be in a sturdy container. And the modes of operation, so the method to connection to internet as an IoT device, and it should also have LEDs that are red for high, yellow for medium, green for low, and have a buzzer alarm when PM concentration is too high. And there should be a local computer connection as well. And this is the air quality index where I got my LED colors corresponding to PM concentration values. And this is the sensor diagram I'll be using. So the particles go up in an updraft and are detected by the LED. And when the light is not detected from the light receptor, those are the pulses that get to the output. And so this is the network diagram. And so the Pika sends its readings to the cloud and then to the IoT server and then eventually to your devices through the cloud. And this is the hardware. So particle sensor, the microcontroller board, LED resistors and buzzers, and the software. So an IoT platform server, the Arduino IDE, Android SDK, fritzing software, and XLively library API, which is the IoT XLively platform. And so for my test plan, I had to test the sensor interface during prototype assembly, the LEDs and the particle sensors, and make sure it's receiving those low pulses from the sensor, and test the IoT connectivity. And here's XLively, and you can see the PM concentration reading below. And so the Arduino Uno board connects to the sensors, and basically my methodology is explaining the different pin numbers connecting to different sensors and what all the cables mean, but I don't have enough time to go over that. And this is my flow chart, which is basically reading low pulse occupancy, LPO duration time. If it's above the time of 30 seconds, then it's going to loop back to no, otherwise it's going to keep going through the flow chart. And then in my flow chart too, I added the different thresholds for the LED buzzers. And then this is my example code. So I initialized LED and buzzer pins and their different modes, and this is another example. And so for my test plan continued, I had to make sure the logic for the PM concentrations worked, and I wanted to test my device in different areas such as indoors as well as outdoors against nephelometers. And here are all my data results for each day that I took it. So I took it with an air purifier in the room, and then with smoke and an outdoor location. And here's all my data readings. And then as you can see, the outdoor location definitely had a higher PM concentration value reading, and the bar chart, it's red, which indicates a high reading of particulate matter concentration. And I also created this app so users can see through their phone that what the particulate matter concentration reading is wherever they put their device to read that specific area. And so my results and conclusion, this Pico was designed and assembled, and during construction, first the particle sensor model was connected and tested, and all of that worked, and the sensor was connected and tested to check whether the sensor can send the PM concentration readings over the serial monitor as per defined BAUD rate to Arduino board. And so it checks all the thresholds, and the LED and buzzer all work, and so does the IoT connection. And those are just some readings, and my average of 191.35 units of PM detection. And as you can see, I have the highest reading for 2660 units, and that is from the lower floor reading, which is probably due to increased foot traffic in the lower floor. And so those are just my average readings. And so for my results and conclusion, my device was definitely low cost and it could sense all the PM concentrations in different environments. And the LED and buzzers worked, and the X Lively IoT website was also reading all of the data points, and you can even access this data from your phone. And it has its own battery unit, and it's very compact. And here's the final design product. And so people can use it wherever they want, and they can get the readings from their phone on the IoT host servers, and it's definitely affordable. And people can avoid the problem of areas with a high PM concentration, take care of their health and respiratory system, and local governments can also take action against climate change and pollutions when they do see these readings from my device. And in the future, I would add an LCD display and an air filter. And here are all my safety and electrical safety procedures were followed. Thank you.